So for this second section of the Seagrass notebook, we're going to be concentrating on aggregating data, and we're going to be using the H3 package in R to create really nice maps that create hexagons to display the data in a nice way that we can then use to create interactive maps as well. So once again, we're working with the Seagrass data. You can see in the previous video how we connect. So yes, check it out if you need it. So we have aggregation of information. So we grab the data set that we downloaded or loaded to our memory rather from the S3 bucket that we call DF. And then we're going to use the H3 index, which is already provided in the dataset that is available in the S3 bucket, to start summarizing things. So we just want to create a number of records that we have for each one of these hexagons. They have a unique ID that it's stored in the H3 index. And then we're going to have information about the data sets. So that's related to sampling campaigns that are available in each hexagon. So we are just going to store that in this variable that is called H3 layers, and here we can see what it looks like. So it has just over 1,700 unique records, and it has 4 columns, including the index of the hexagons. We have the data sets that are available at each hexagon, the total number of records, so that's the observations, and then this is an index that will help us do the maps. So once we have that information, we can use Leaflet to create these interactive maps. Then we add tiles, which essentially is just like a base map. Then we add the polygons, and then we provide our H3 layer variable. We need to give it an index, the unique index, so it can create the hexagons. So that's provided in index, as you can see here. That's the S3 information there. Then I'm using color quantiles here, mostly because it just groups the data in different quantiles. So it's easier to see kind of the nuance in the coloring. Otherwise, it will be washed out. So I'm just using the plasma color palette. The domain refers to all possible values that we're going to be plotting. N10 just refers how many quantiles we want to use, and then we provide again the domain to which we're going to be applying this information. Then this is just to make it nicer, kind of don't make it too dark, have like gray around the hexagons, and this labeling is essentially the label that we get when we hover over these hexagons, which is going to be changing, as you can see, based on where we place our mouse. So we can also zoom in and out. So as you can see here, there is data for most of Eastern Australia. So we have, again, different data sets, different numbers of records for each hexagon. So we have the different Australian marine regions. You can have a look at the links for information about what these different regions are supposed to be referring to. So we do something very similar to what we did before. So we take that data frame where we have the information about seagrasses. We want to make sure that we get information about the different tags or the different classifications that are attached to each observation. We count them, and then essentially we just kind of do the same thing. We get the data sets that are unique to each hexagon, the number of records that we have available in each hexagon, and also the unique tags that are available in each hexagon. So once we have classified or kind of summarized everything using our H3 index, so we have the number of records, the number of data sets, and the unique tags for the Australian marine regions, then we can have a look at our result, and basically it has an index, as you can see there. It has all the tags available for that particular hexagon, all the data sets available, as well as the number of records. And this index is what we're going to use to create the maps. So we provide that to Leaflet once again as the data. So it knows how to plot these polygons. We use quantiles again. We use the same amount of separations. It's actually 10 quantiles. We make sure that we provide that domain. It can be the number of records because that's what we want to show. We're just going to make it nicer. We're going to define what's going to be available in the label, and then we can see the result. So as you can see, if I move my mouse, it will provide different information. So the warmer colors have a higher number of records, while the cooler colors will have the lowest number of records. So then we can also use a different criteria to filter information. So we can use, we saw that there are multiple marine regions. So let's say that we're interested in tropical waters, we can filter using that information. So the regions are in a single line. So we wouldn't necessarily go regions equals tropical waters, but we want to use the stringr library so we can detect patterns. So that's why we use str detect rather than simply going Australia marine regions tags equals this, because it can be contained together with other tags available from the Australian marine regions. So once again, we make sure that everything is summarized using the H3 index. But I'm actually going to show you as well how we can create that index. So let's say that we don't want to use the index that has been provided in the dataset, but we want to make it a smaller or a higher resolution. It doesn't matter. So we're going to ignore the H3 index that is available in the dataset. We're going to filter for tropical waters, and we're going to transform these to a shapefile essentially by using the STSF function from the SF package. So once we have that, we can use our H3 package, specifically the function called geo to H3. So geo as a geo reference. So it immediately recognizes shapefile. So we just provide the shapefile, which is called tropical waters, and then we just give the resolution. In this case, is 7 that we want to try. You can try any number really. And then we are just going to overwrite that shapefile. And then we're going to do essentially what we did before. We're going to get the number of records that are available at these new hexagons that we just created, and the unique data sets that are available within those hexagons. And then we do the same thing with Leaflet. We provide that information that we now call H3 layers. We're just going to use the number of records to create those quantiles and to create this new map. So as you can see, it's more sparse, the data that we have available, and that's because we actually selected only data that is associated with tropical waters, and the size of the polygons is also a lot smaller, as you can see here. But then the colors that we're using still are kind of follow the same pattern as before. So the warmer colors will have a higher number of records, so just over 1,000, while the cooler ones will have lowest, so 70 records in here.